Welcome to the final example of chapter 1, example 1.5.14. I wanted to do a harder example where you had to find a coordinate vector and a coordinate vector map for a vector space that was an Rn. So let me take this subspaces of P2. P2 is the space of polynomials of degree 2 or less. So all polynomials of degree 2 or less, so that P of 2 is 0. So I want to find a basis for it first. I'm going to start with a polynomial of degree 2 or less like this. Then P of 2 is a plus 2x plus 2b plus 4c. It's the x that I'm replacing. Sorry about that. And I want this to be equal, so that gives me a linear system. Pretty simple one. It's already reduced. And so I'm going to get that a is minus 2s minus 4t, b is s, c is t, and so I will get abc minus 210s plus minus 401t for s t in R. Right? Each of these vectors represent a polynomial. I'll translate them back. And so my basis is going to be, the first one I have a equals minus 2, b is 1, c is 0. And so if I plug that back into my starting polynomial, I'll get minus 2 plus x. The next one is a equals minus 4, b is 0, c is 1. So in that case, I get minus 4 plus x squared. All right, so here's my basis. Notice that if I actually started with ax squared plus bx plus c, I would get a different basis. I like this one better, which is why I flipped it that way, but it would be as right to do it the other way. All right, so let me take some random polynomial in V. I want to give a formula for psi of B, so for its coordinate vector. So I'm going to rewrite P of x, which is a plus bx plus cx squared. I want to write it as something times minus 2 plus x, and something times minus 4 plus x squared. But notice that this is the only x squared in any of the terms, and so c is going to have to be the coefficient here, and then this one is the only x, and so b is going to have to be the coefficient here. And just to check that the constant match, because I haven't used that, if I look at the constant, I would get that P of x is minus 2b plus minus 4c. Sorry, I need more. Oh, I need a bit more room. And then I'll have bx plus cx squared. So I took the only choice that would make this right, but I just want to check that the other one's right as well. I get minus 2b minus 4c, but notice that we have this because we're not anywhere, we don't have a polynomial from all of P2, we have one from V, and so we know that P of 2 is 0, so we know that equation is true. And so minus 2b minus 4c, that's A. And so that means that psi b of a plus bx plus cx squared, that's equal to, well, it's always p of x. So it's going to be the coefficients in front of both generators. And so in our case, that's pretty simple. We're just going to take b and then c. All right, so we've found what the psi b was, and in C we're asked to find its inverse. So the inverse would have to start in R3 and land in the space of polynomial, and it would have to send, sorry, it's P, not W, so it would have to send the coordinate vector to the polynomial. I'm sorry, I wrote P of X, but I mean V. All right, so if I have, let's call them not X, X is bad. I don't want to put B and C because it's kind of giving it away, so I'll put D and E. If I have two vectors, then a vector of two components, then it's going to be D times my first basis vector plus E times my second basis vector. So this map is actually easier to get because all you have to do is take the components of the domain and multiply them by your basis vector, and what you get, you get. And so here we would get EX squared plus DX, and then the constant is minus 4E minus 2D. All right, that's the map.